Hello, so in today's class, we will look at this problem. So the question is to find the number of permutations of 5 letters A, B and C. So here you need to arrange 5 letters where 3 of them are repeating. So this is a kind of permutation where some objects are repeating. Okay, now for solving this problem, so let me take alpha to be the required number of permutations. അപ്പോൾ നമുക്ക് ഈ 5 elements arrange ചെയ്യുമ്പോൾ you will get different number of arrangements. Let me call those number of arrangements to be alpha. So let the required number of arrangements be alpha. And now consider one such arrangement. അപ്പോൾ നമുക്ക് ഈ എലമെന്റ്സിനെ പല രീതിയിൽ അറേഞ്ച് ചെയ്യാം. അതിനകത്ത് ഏതെങ്കിലും ഒരു അറേഞ്ച്മെന്റ് എടുക്കുക. So consider one such arrangement. Say let me take the arrangement A, B, C, A, A. So this is one of the arrangement of the 5 objects A, B, C. ഇനി നമ്മൾ usual permutation എടുക്കുമ്പോൾ, so if all these 3 A's were distinct, അപ്പം ഈ 3 A's distinct ആയിരുന്നെങ്കിൽ, so if I have first A to be some A1, then B, C, then you have A2 and A3. So if these were 5 distinct objects, അങ്ങനെയാണെങ്കിൽ നമുക്കിതിനെ 5 factorial ways arrange ചെയ്യാമായിരുന്നു. Okay, so provided they were distinct, they could be arranged in 5 factorial ways. Now let us look at, provided this was distinct, എത്ര തവണ ഈ same value repeat ചെയ്യുന്നുണ്ടായിരുന്നു നമുക്ക് നോക്കാം. Okay, so let us imagine that the 3 A's are distinct. So imagine that 3 A's are distinct. Say, so let us take it as A1, A2, A3. Then A, B, C, A corresponds to or A, B, C, A can be arranged as, so you can arrange as A, B, C, then A1, A2, A3, then A1, B, C, A3, A2 arrange ചെയ്യാം. Then you can start with A2, B, C, then A1, A3, then A2, B, C, A3, A1. Then you can start with A3, B, C, A1, A2, then A3, B, C, A2, A1. So provided these 3 A's were considered to be distinct, അങ്ങനെയാണെങ്കിൽ നമ്മൾ ഈ distinct permutations എടുക്കുമ്പോൾ distinct 5 factorial permutations ഉണ്ട്. അപ്പോൾ 5 factorial permutationൽ A, B, C, A would be repeating in 6 ways. So that is in 3 factorial ways this is repeating. അപ്പോൾ ഇതിൻ്റെ അകത്തെ നമ്മൾ ഓരോ permutationും when you take in the case where these 3 are considered to be repeating distinct, so each entry or each arrangement will be repeating 3 factorial times. അപ്പോൾ 3 factorial into നമ്മുടെ required number of alpha എന്ന് പറയുന്നത്, so when you take all these repetitions, that is like arranging 5 distinct elements. So this alpha into 3 factorial will give you 5 factorial. So that will give the required number of alpha. So let us write that. So this implies A, B, C, A corresponds to a set of 3 factorial permutations of the set A1, A2, A3, B and C. So if you take the permutation of the set A1, A2, A3, B, C, so out of that the 3 factorial permutations will be that of A, B, C, AA, where A1, A2 and A3, they are 3 A's are considered to be distinct. So keeping the pattern, so this pattern remains the same, A, B, C, A, A. And since there are 5 factorial permutations of A1, A2, A3, B, C, so that implies alpha into 3 factorial will be equal to 5 factorial. So alpha will be 5 factorial by 3 factorial. So that is 5 into 4. So you will get alpha equal to 20. So the required number of permutations will be 20. So we can generalize this into a new result. So in general, we have, so the general result is as follows. So consider a collection of R objects in which R1 are of type 1, R2 of type 2, etc. Rn of type n, where R1 plus R2 plus etc. Rn is equal to n, is equal to R, sorry, so that is R. Then so here you have total R objects. Out of the R objects, type 1 is repeating R1 times, type 2 is repeating R2 times, and type n is repeating Rn times. But total, the sum of the total objects is R. So each object is repeating these many times. Then the number of different permutations, so that is denoted by P of R semicolon R1, R2, etc. Rn, and the number of permutations is given by R factorial by R1 factorial, R2 factorial, etc. Rn factorial. So that is the required number of permutations. So if you have R objects where R1 is of type 1, R2 of type 2 and Rn of type n, then the number of different permutations will be R factorial by R1 factorial, R2 factorial, etc. Rn factorial. So let us see the proof for this result. So you have R objects. Now let us start with the first object. So in any permutation of collection of R objects, so there are Ri positions to place the object of type I. So നമുക്ക് type 1 ന്റെ object R1 ഉണ്ട്. അപ്പോൾ type 1 ന്റെ object R1 places arrange ചെയ്യണം. type 2 R2 places and type N you have to put in Rn places. So in any permutation of the collection of R objects, there are Ri positions to place the objects of type I, where so I is equal to 1 to etc. n. So you have objects of type 1, type 2 and type n. Now let us first place the R1 objects. So we first choose R1 positions for type 1 objects R1 ആണ്. അപ്പോൾ ആദ്യം R1 objects arrange ചെയ്യാം. So we first choose R1 positions for R1 identical objects. For choosing R1 positions, so total there are R positions, so that can be chosen in RC R1 ways. So this can be done in RC R1 ways. Ini nammal out of R positions R1 positions il type 1 object place chedu. Now remaining there will be R minus R1 positions. Now next, so we need to arrange the R2 identical objects in the remaining R minus R1 positions. So next we choose R2 positions from remaining R minus R1 positions and place R2 identical objects. So this can be done in, അപ്പോൾ നമ്മൾ R minus R1 ന് R2 positions choose ചെയ്യുക. This can be done in R minus R1 C R2 ways. ഇനി ബാക്കി R3 നെയാണ് ഇനി പ്ലേസ് ചെയ്യേണ്ടത്. R3 objects അത് നമുക്ക് R minus R1 minus R2 placesൽ പൊസിഷൻസിൽ നമുക്ക് പ്ലേസ് ചെയ്യാം. So continuing this way, we choose, so let us see for the last one. So we choose Rn positions from remaining R minus R1 minus R2 etc. Rn minus 1. So that is equal to Rn. So positions and place Rn identical objects. അപ്പോൾ ലാസ്റ്റ് Rn objects place ചെയ്യാൻ നമുക്ക് exactly Rn positions ഉണ്ടാവുള്ളൂ. So and place the Rn identical objects. So this can be done in R minus R1 minus Rn minus 1 C Rn base. So that is equal to Rn C Rn. Okay, so that is equal to 1. And now by multiplication principle, so let us take the product of all this. So that will give us the required identity.